Okay, so how do you test for oxidizing agents? Okay, we have 3 tests for it. Okay, if a substance is oxidizing agent in nature, you're going to liberate iodine from acidified potassium iodide. Okay, forming a brown solution that turns blue-black when starch is added. The next one is using hydrogen sulfide. A yellow sulfur is deposited due to the oxidation of the sulfide ion. I think the next one is when ion 3, this is covered, the picture covers the write-up. When ion 3 salt, which is brown, when ion 2 color, which is green, changes to brown, that shows that that compound contains what? Oxidizing agents. All right? So this is a clear example like this. This is from this to brownish color, so this is an oxidizing agent. All right. Then the last one is a test for reducing agents. All right. Now we have 3 tests also. The first one is very popular and very common. Reducing agent will decolorize acidified purple potassium tetraoxomanganate 7. As you can see here now, this is manganese 7. If this compound contains reducing agent, this color will change to a neutral color. All right. The next one is reducing agent will change orange or yellow color of acidified potassium heptanoxydichromate 6 to green. As you can see in the diagram, this is the green part, the orange color of K2Cl2O7 that changes to green. Then the last part is the opposite of ion 2. Okay, when ion 3 changes from brown to green. Okay, ion 3 changes from brown to green. That shows that that compound contains what? A reducing agent. All right, let's look at some reference question, WAEC past question from this topic. How can you treat some question? This is theory part of the question. But the question is, what is redox reaction? It's very simple. You can define it in many ways, as far as the concept is there. Either in terms of oxygen, electron transfer, electropositive element, addition of hydrogen, and so on. But make sure the concept is there. For example, I said a redox reaction is a reaction that involves both oxidation and reduction of species. One being oxidized by losing electrons, that's the meaning of oxidized, and the other being reduced by gaining electrons. Or you can say is a reaction that involves a change in oxidation numbers of species. Or you can also say it involves the transfer of electron or addition or removal of what? Any one of these will give you a full mark. Pick the one that is easier for you and you define. Then the next one is identify which of the following reaction equations are redox. You can go back to the video, pause and go back to the previous slide. I've explained more examples of redox reaction. Why are they redox? I said not all reactions are redox. For example, we have I to IV. Which of these reactions are redox? Look at it critically. Look at it and be able to know which one is redox or not. Now, this is sodium. Okay. On the neutral state is 0. Neutral element is 0. Chlorine here is what? Is 0. All right. Now, this sodium chloride is when you split this compound, it will give you Na plus what? Cl minus. Is that okay? So at this point, is equation 1 redox? Yes, because there is a loss and gain of electron. Okay, so from this point to this point, there's what? Loss of electron. Sodium lost electron. Sodium here is 11 atomic number, but here is 10. It has lost electron. So at this point now, chlorine have the what? Gain electron. Chlorine here is 17 by atomic number, but by becoming minus, it has gained 1 and becomes what? 18. Of course, I is a redox reaction. But let's say II. No, this is not a redox because a complex is formed at this point. So there is no transfer of ion. All of them comes together and form a complex. So this is not a redox reaction. Is that okay? Let's look at II. Is this redox reaction? No. This is an example of what? Of a neutralization reaction. Why? Because this is an acid. Reacting with a base gives us what? Salt and water. So there is no loss of electron, there's no gain of electron. The only what? Displacement takes place. But this is no redox reaction. Alright? This is no redox. Look at the IV. Is this redox? Yes, this is a redox reaction. Why? Now let's break this into their various charges. Okay, so at this point now, iron here is +2. Don't forget, chlorine here is -1. If you break this compound, it will give us K plus / I minus. Is that okay? What is the charge of iron here? +2. Chlorine here is still what? -1. All right? Break this into your charge. You're going to have what? You're going to have K plus and what? Cl minus. Whereas I here is what? Is 0. Is that okay? So look at it very well. So from this point to this point is called what? This is, sorry, +3. There is what? Reduction process. Iron have do what? Have gained electron. Is that okay? Whereas from -1 at this point, okay, so where you have the iodine, iron here have lost electron. So this is an example of what? Of a redox reaction, because there's a transfer of electron. One is gaining, another one is losing. That's when you have answer as I and IV. Okay, let's look for other example, other questions. Give a reason for each of the answers. Okay, I've done that already. This is how the question comes. Okay, so you can go back to the previous slide and check where it's done. This is just the answer, right? There is a increase of sodium from 0 to +1, loss of electron, whereas chlorine decreases from 0 to -1 in that same first electron. So that is a reason why it is a redox reaction. Then for the point number 2, you can see it affected what? Ion. All right? Ion gain an electron rather from +3 to +2. All right? So that is why it's redox reaction, whereas iodine do what? Lost an electron from -1 to what? To 0. So that's the reason why the reaction is what? Is a redox reaction. All right. Another example is write a balanced equation of the half reaction for any of the 2 redox reactions. It's a continuous question. All right. Don't forget. So if you don't know which one is redox reaction, you cannot write the equation for it. So you must be careful when you're choosing a question to answer, because you must answer it according to the way it's being asked. Now, this is the equation of reaction to show that this is what? Their reaction equation. And don't forget that we have done this before. I've shown you how to write redox reaction and balance. So in this case, you are asked to do that based on the question. So this is the reason why this reaction is redox. Because at that point, sodium becomes this form. Okay? From this to this, and you balance it by 2 electrons, because sodium is 2, you balance it up. Then from the chlorine, from 0 to what? To minus, and you balance to correspond the charges. Here, charge of chlorine is -2, then charge of chlorine is -2. So everything is balanced and well split. All right, then the next one is ion, okay? From this point to this point is what? This is your reduction process, okay? Then from this to this is called what? Yes, it's oxidation, because ion do what? Lost electron from minus to what? To 0. All right, so this is how we show that it's being split into the half equation. And not only to split, you must balance it when you're splitting your equation. All right, let's look at other question. Element J has the following electron configuration: 1s2, 2s2, 2p6, and 3s2. The question is, state whether J would be a good oxidizing or reducing agent. Then the following question is, give a reason for the answer in A above. There must be a reason behind this. So it's very simple. First of all, remember what is oxidizing agent and what is reducing agent, and why is it so? Now go back to the question, what is J? If you can identify J, it will give you a clue on what you're supposed to do. What is J in this equation? 1s2. So how do you know J? All this stands for their what? Atomic number. Okay, so this is by element. This is 2 plus 2, 4. 4 plus 2, 10, 10 plus 2, 12. So your J here is what? Is magnesium. Is that okay? And magnesium is in group what? Is in group 2. So what is the charge? Is having a charge of +2. Okay? And I said that all metals are what? All metals are reducing agents. Don't forget. The non-metals are what? Oxidizing what? Agents. So they just give you an indirect question. Now, if you don't know what J is, you cannot answer this question. So you must take your mind back to periodic table and electronic configuration to identify the elements. That will give you an easier part to do what? To know whether you can answer A or B. All right. So with this now, state whether J would be a good oxidizing agent, or, of course, what is the answer now? Before I give you the answer, you know the answer now. All right. So what is our answer? it will be a good word reducing what agents. Why? You're going to lose the 2 electrons and become stable. Now, give a reason. Okay, I've done it already. Let's look at the reason. What is the reason for the answer? Because it's going to lose electron. How many? 2 electrons in its outermost shell. Okay. Or it readily gives out electron. Or you can say electron donor or electropositive elements. Either of these will give you your full mark. So you must identify this by the electronic configuration. This is an indirect question. And this is how questions of these days normally comes in a trick form. All right. So let's look at other examples, other questions. Consider the reaction represented by the following equation. Now this is your complete balanced redox equation. It's balanced already. Now the question is, write down the species undergoing reduction. Don't forget, there is always reasons, so you must give reason for your answer. If it is asked, you must give reason to get your full mark. Now, which species will undergo reduction? And I said this before, that the species will come from the reactants, not from the product. Take note of that. You will not get this answer from the what? From the products. You will get your answer from the reactants. Is that okay? So what is reduction? Reduction is defined as gain of electron. Don't forget that. Addition of hydrogen, removal of what? Of oxygen. In this case, I'm going to look at the oxidation state and you know the answer. Now, the charge of manganese in this compound is what? But this manganese 4 oxide is +4. All right? Now, manganese A is +2, as you can see, +2. All right? So, from +4 to +2, what process is that? Is manganese losing electron or gaining? Of course, it is what? It is gaining electron. So, it is Mn that undergoes the what? The reduction process. It's very easy. Now, give reason for your answer, because it what? It gains an electron. Now, the reducing agent is what? I said that if this is from this point to this point, okay, is one process, and then from this point to this point is what? Is one process. So if this is reduction, here is what? Oxidation. Is that okay? So the reducing agent is what? What gives rise to reduction? Reduction is what? It's called oxidizing agents. This is a trick behind this kind of question. So you must reason fast to get answers to this. If not, you mix up the concept. Okay, let's go. MnO4, I said that before, is what? MnO4 is the answer, is undergoing reduction. Why? Because oxidation number of Mn decreases from what? From +7 to what? To +2. Rather, sorry, it was +7, not +4. +7 to +2. Is that okay? So at this point now, reduction takes place. Now, the next part of the question says, the reducing agents give the reasons. So this is my reducing agent, all right? Because from this point to this point is what? Is oxidation. Okay? So what causes that is your reducing agent. Because the original number of carbon increases from +3 or to +4 and so on and so forth. So it's very easy. Just don't rush in this kind of question. Take your time, analyze it before you can pick your answer. All right. Then let's look at another question. In terms of electron transfer, define oxidation and oxidizing agent. This one is a bonus question anyway. What is oxidation? They have given you a condition. Don't forget, in terms of electron transfer. So your answer should be in terms of electron. Don't go and say addition of oxygen is wrong. Follow the term and condition given to you. So what's the answer? Is a process of electron loss. All right? Because you are given the concept already. In terms of this, define this. So in terms of this, what should be this? Is it electron donor or electron acceptor? So let's look at it now. Is electron what? Acceptor. Why? Acceptor. All non-metals are what? Oxidizing agents. What of metals? Reducing what? Agents. Okay. Balance the following redox equation. I've shown you this already. I know how to do that, but this is another different equation entirely. Okay? Another different equation entirely. So it's very simple to do that. First of all, identify your reduction agents, your reduction process, which is from this point to this point is your reduction, while this to this is your what? This is your reduction process. If you can do this alone, it will help you. Then this to this is your what? is your oxidation process. So this will give you a clue on what to do. So having done that, what do you do? I say you should first of all balance oxygen with what? With water. So that's how we have 4 H2O here, because we have 4 atoms of what? Of oxygen. Okay, having done that, we have introduced another element which is oxygen. Sorry, hydrogen. How many? 8. So 8 is balanced by what? By hydrogen ion. When you have done that, balance the charge. So what is the charge? -2, -1 plus 8 is what? Is plus 7. Then here we have plus 2. So how many electrons should I add to make it plus 2? So 7 minus 5 will give us plus 2. That's why we have the plus 5 electron. What's the next step? Alright, the next step is to do what? Before this, let me bring this up so you know the reason why I brought this in. Alright, so the next step is to know what your oxidation half equation from iodine ion to what? To iodine is oxidation. Balanced by what? By the atoms, 2 balance the atom. Note that the electron is balanced, right? By adding 2 electrons to it. Okay? Alright. Okay, so I want to talk on this now, so to now say why do we have this and this. The reason why we have this 10 electron here is to correspond with the 10 electrons in this form. Alright? Because initially we have 5 electrons. Let me call this equation A. 5 electrons in electron A. Is that okay? But here we are having 2 electrons. Call this B. So we cannot equate this electron because we have various electrons. The best way to have this is to do what? Is to multiply this by 2 and you have 10. That's why this 10 comes in here. So that we can have 10 electrons in the reduction half and multiply this one. If you multiply this by 2, you have 10. That's why you have all of this by 2. 2. And you have this. Multiply this by 5 and you have this electron here. Alright, so they can equate it. Okay, so having done that, note the way it is done. Having done that, what is the next thing? You will sum the 2 reactions together. Add equation 1 to equation 2. How do you add it? Reactant to reactant. So the whole of this comes together. Reactant to reactant, okay, as you can see, this is the whole of the reactants from the 2 equations. This is the whole of the the products from the 2 reaction equations. Alright? When you now do this, what is common? The 10A minus is common. The 10A minus is common. When you cancel that one out, what you have left is your complete balance equation. It's very easy. Just take your time, pause the video, look at it critically, and you get the concept. Alright. Then question 5, consider the reaction represented by the following equation. Okay, state the species that is undergoing oxidation and oxidizing agents. Is very simple. How do you know it? First of all, identify your processes by their charges. Okay? By their charges. Alright, so at this point, let's use this. I don't want to waste much time on this again because I already explained it in the previous video, previous slides. This will tell us more. Alright? Why is this compound like that? Alright? Sulfur here is -2. Sulfur here is 0. So for -2, we should process loss of electron. So that is why this H2 goes for what? Oxidation. Because this guy is oxidized. Is that okay? Then what should be our oxidizing agents? What causes reduction is known as what? Oxidizing agent. SO2. It's as simple as that. Alright? So just take your time, study the video very well, and you get to understand the concepts, and it will help you. So let's take a brief break. When we are back, we continue from here. Thank you.